Hello dear students, once again welcome you all to the course on manufacturing methods. So in the previous lectures we have already discussed about the introduction to casting and all. We know the processes involved in casting, okay, the various steps involved, and we all already know about the cooling behavior or the solidification behavior. Okay, so those things already we have discussed. Later on some difficulties in sometimes feeding, that is CFR, about those things also we have discussed. And now today basically we are going to discuss about certain melting furnaces and one or two types of different types of special casting methods. Okay, so now see, as we already know from the foundry process, okay, the first and foremost step in the process itself is to melt the metal. And now to melt the metal, what basically we use? We basically use various furnaces for melting the metal, okay, in the liquid form. Okay, so that is the molten state. Okay, so now in case of this for melting the metal, okay, so we use different melting furnaces. So there are various types of furnaces which are being used in foundry process, which are like some of the examples are like cupola. So we also use direct fuel fired furnaces. Crucible furnaces are also being used. Electric arc furnaces are also being used. Similarly, induction furnaces are also used. So all these furnaces, what is the purpose or objective of using this purpose? So basically these furnaces are used to melt the metal. Okay, that means to achieve the molten state of the metal, so as to later on we will be able to process with that particular molten metal. Okay, now as you can very easily see, there are a variety of furnaces involved, and now the question comes, which furnace is best, which furnace is good for use and all. So in that particular case the answer is all the furnaces are good and all the furnaces are having their unique characteristics. So it basically depends on our requirement. Okay, or our requirement means there are if we discuss about the selection of the most appropriate furnace type, it what are the main factors which are responsible, or what are the main factors which we look for while selecting a particular furnace for melting the metal. First is the casting alloy itself. Okay, so what is the casting alloy we are working on? Okay, and what is its melting or the pouring temperature? Based on that, definitely the selection of one type of furnace will be there. Okay, similarly all the furnaces will not have equal capacity. Okay, so based on our requirement, that means how much molten metal we want to have and all. Okay, so based on that also, and how much at a particular, what is the production rate, you can consider like that, that is in terms of capacity. Okay, so that is also will be one factor. Okay, if like we need suppose a particular capacity, okay, then we have to go for a particular type which is suitable for this, and so on. Similarly, and whatever raw material we have from which we want to melt, okay, what is its size and what is its shape? Based on that also we have to select a proper type of furnace, because all the furnaces, depending on the furnace, okay, size of the furnace, it will be able to accommodate a certain size of raw material only. Similarly, sometimes there may be limitation in terms of shape of the raw material. Okay, so based on that also sometimes the selection of furnace is limited. Okay, similarly, depending on what is the cost of investment, what is the mode of operation and maintenance cost, etc. involved, and what are the expertise that you have in your locality or you're available for you. Okay, based on that also we may have our this kind of furnaces. Similarly, there are, all of you already know nowadays, pollution, that is environmental degradation and pollution related to different processes and all. Okay, there are strict pollution norms, okay, which are already set up in various developed countries, and in our India also new pollution guidelines are coming. So based on that also, as we are talking about melting the, you can say, metal with the help of this furnace, so very easily all of you can say a tremendous amount of heat will be involved. Okay, we have to supply heat externally so as to elevate the temperature of the raw material and to achieve its melting point, then only it is going to be melted. Yes or no? So for that also we have to incur a huge, you can say, energy supply will be there. It is it may be in terms of heat and all, or that particular heat supply, it may be by burning of fossil fuel, maybe by electrical methods and all. There are various ways available. So this is one of the under consideration, environmental pollution consideration. If your regulation, that means the if the law admits you or permits you up to a certain level, maybe you can go for a certain type of furnaces, okay, old type of furnaces, or to mitigate the or to lower the environmental pollutant level, then we may have to go for some other advanced type of induction furnaces or electric arc furnaces, that kind of furnaces. Okay, now the optimum temperature after the melting is over, okay, it is basically decided by a property of it, and that is nothing but the fluidity of the metal. Okay, so what is this particular fluidity, which is very important in terms of casting? So this fluidity, it refers to the relative ability of the liquid metal to fill in the mold at a particular temperature. So now if the fluidity of the molten metal is high, then it will be easy for it to to penetrate through all the nook and corners of whatever is the mold cavity that we have. And if the fluidity of the molten metal is very less, in that particular case, what will happen, depending on the fluidity level, it may not, suppose the molten metal may even get solidified before it reaches all the nook and corners of the mold cavity. So this is one of the very, you can say, the important characteristic of the molten metal. Okay, what is the fluidity that we have achieved? Okay, so now there are various furnaces involved, and we'll be discussing in brief, but what will be your assignment? Your assignment is you have to go through the various types of furnaces with their specific use, that means when we use it and what are the capacity of heat, etc., and you can turn it in as an assignment. Okay, so in this particular figure I have included some of the type of furnaces which are really used for in versatility use. So first figure, it shows a cupola which is used for melting cast iron basically. Okay, this is the cupola. So it has got very parts. Suppose the exterior hub we have, okay, the ceiling we have, we'll have some wind box, and like definitely we have the surging door, okay, surging floor we have. Okay, so from here we like the blower will be there, okay, and all those things. That means ultimately we are going to hit this particular interior, okay, and we want to melt that particular molten metal. And later on, like various from the design consideration, this figure itself is self-explanatory. Okay, we can very easily say that later on we are going to get the, you can say, molten metal in case of by using this cupola. Okay, similarly we can have different types of crucible furnaces. So various types of crucible furnaces we are showing here. The first one is lift out type of crucible, okay, second one is stationary type of pot, third one is kind of tilting type, so the name itself suggests. So from the first one we can see that it is, we have to lift it out, that means after whatever is the molten metal we have achieved, to lift it out. Similarly from the third one you can see that there is provision for tilting it, tilting the whole furnace, and we can get out the whatever is the molten metal. Similarly, one of the other advanced way, less pollutant type, okay, pollution is the induction type of furnaces. So in this particular case, so in the case of this induction furnace, basically we'll be having the metal inside the refractory material concept box, okay, for enclosure, and generally we have this copper induction coils around it, wounding around it, and due to the induction force, okay, inductive action, basically the heat gets generated and it melts the whatever is the raw material that we place inside. Okay, this is how basically this induction furnaces work. So here the heat that we can receive is kind of more. So now I request all of you to go through these different types of furnaces in brief, okay, from any of the books, and you can turn it as an assignment for this course. So this is basically about the various types of furnaces and the ways, that means to melt the metal, okay, raw material to its molten form. Next, once we have already discussed about, it means the first step itself is kind of melting the metal, okay, then we pour it, okay, we let it solidify, okay, and after that, depending on whether it is expandable mold process or permanent mold process, we either break the mold to take out the cast, or we have to we'll just open it so as to take out the cast. Okay, so now even though we know that this casting process in most of the times it can be a near net shape kind of process, that means at a single probe it's possible to impart all the you can say whatever is the final dimension as well as whatever is the different types of processing it is required, that is possible. Okay, even kind of, you can say, like we can even give the holes, okay, already, which is imparting in the cast, okay, which will be there in the cast. So that is possible, okay, we don't have to go for secondary process. Similarly, it's possible to give rise to certain surface textures, maybe thread, etc. also is being, it's also possible to cast in a single go, but it's not always so that each and every time we'll be casting it to the final shape, okay, and there may be sometimes, depending on the requirement, there may be certain additional steps which will be required after the solidification process is over, okay. So some of the additional process after the solidification process is over, and we take out this particular process. First one is trimming. So trimming is nothing but like sometimes some blur, some edges may be there, okay, in the cast part, okay, and similarly sometimes all those, in many times the extra parts like the, you consider risers, the other different types of runners, etc. will be there, which will just trim those unwanted parts, okay, and those trim parts which is made of the same metal, okay, which has already been solidified, it can be reused, it can be re-melted and can be reused for the other process. Similarly, if we have used a core during the casting process so as to give rise to internal face, okay, the texture or whatever is the geometry that is there in the internal geometry, okay, maybe it may be hole. It is also possible to like suppose if consider as if it is a hole, and that hole has got something, some in that particular hole maybe there is some texture on the face, okay, that is also possible. If you just texture the correspondingly you just texture the core, and if you place that kind of texture core, so based on that, after the solidification process is over, in the cast, okay, cast is nothing but the final product we obtain after casting. Cast is the product, okay, the final cast, it is possible to have texture in the internal surface even, okay, by the help of the core. So that core, if we have used, we have to remove it. Similarly, surfaces we have to clean it. Sometimes some scaling is there, sometimes some oxidation is there, so those marks we just have to clean it, clean the surfaces and all, or sometimes some embrittlement, some extra suppose in the case of sand casting, maybe some sand, it may be there in the surfaces, okay, so those cleaning will do. Next, definitely one of the most important tasks is to do the inspection. So in that particular inspection, it is kind of, you can say like quality checking kind of thing, okay. We will inspect the cast, okay, whether it is there any fault, whether it is dimensionally correct or not, is there any crack, etc. If it is there, we have to reject, or whether we are going to accept or reject that particular part, okay. So that kind of inspection we have to do, and if we find some problem which can be resolved, then we go for repair if it is required. Then sometimes if depending on the type of part that we are manufacturing by casting, okay, we heat treat it, okay, because in the casting process sometimes we don't get whatever is the fiber flow range that is required, okay, and the hardness, etc. Okay, so as you already know, heat treatment is one of the versatile used process for enhancing the mechanical internal properties, okay. So optional heat treatment we can go for, okay. So next, till now we have discussed about the casting process, okay, in a generalized manner, okay. What is casting, okay, what are the basic steps involved in any kind of casting, okay, normal casting, you can say the foundry process, etc., the solidification behavior, etc., etc., those things we have discussed. Now apart from the normal casting, whatever we understand by the term casting, okay, there are certain special casting methods. Now why these special casting methods are required, okay. So the answer to this question is, see, by the help of the special casting methods, the productivity can be increased, okay, the increase in production rate, that is possible, okay. Similarly, sometimes to improve the quality of casting, okay, depending on our requirement of the part, okay, we may have to go for some special casting methods. Similarly, if we want to, it's kind of totally net shape manufacturing process, if we have to go for, we have to have, and also we have to go for certain special casting method, that means to eliminate or minimize the need of further machining. So in a single step, whatever steps we would have we are going to utilize, or we are going to process in other machines and all, maybe making holes, maybe making threads and drilling the holes, and all those kind of optional secondary processes. Okay, so we can even minimize or reduce those steps involved, and we can get the final product in a single go. For that also, that is also possible by different special casting process. Similarly, to provide better dimensional control, that is also possible. To produce parts having better surface finish, that is also possible. Okay, and similarly, from some economic consideration point of view, sometimes certain different types of casting which are comes under the special casting method, they will be possible. So those kind of things basically in the subsequent lectures we will be discussing in details in some of the special casting process. Now coming to the expandable mold casting process, so some varieties we have listed down. So what is expandable mold casting process? Okay, expandable mold means in this particular case the molds whatever we make, it is for a single part, or it is for a single cast. Okay, that means once the solidification process is over and we want our product, okay, which has been already solidified, so for taking out that particular product in the expandable mold process, what we do, we have to break that mold. Okay, so the most basic type of expandable mold process is the sand casting, which I believe most of you have already seen, maybe sometimes in the villages, in the town areas also. Sometimes some small hawkers, they come, okay, they manufacture some you can say some show pieces and all out of your uh, some metal, okay, maybe aluminum, that kind of metal utensils, suppose kitchen utensils, etc., which are available in your home, okay, which is not being further used, and previously they used to come and they will just melt it, maybe the 11 pieces is not, and as per your requirement, basically they have a box of sand, and they already have a particular type of, suppose whatever is the showpiece, okay, and they will have the impression there. That means they are creating the mold, and after that whatever utensil you give, they are going to melt it and they will pour it there and let it solidify, and after that at a certain price they will be giving you that particular whatever is the showpiece and all. Maybe some of you have had this particular experience, you might have seen this in some melas or some fairs or whatever, maybe in your locality also. So that is one of the most basic, and that is sand casting. Similarly, we have cell molding, which is one of the most another one, which is, and similarly we can have vacuum molding, we can have expandable polystyrene process, we can have investment casting, which is one of the most sought after type of casting method, okay, also known as the lost wax processing. We can also have plaster mold and ceramic mold casting. So in our subsequent lectures we'll be basically discussing about this cell molding, will be discussing in details. Similarly, investment casting will be discussing in details, and some of the other methods. Already sand casting, about sand casting we have already discussed, we already know, and some the others will just have a discussion. Okay, so for today we conclude this session here. Okay, in the subsequent classes we'll be discussing more about the different types of special casting process. Thank you.